Section 10.1, matrices and system of equations. So if we have m and m are positive integers, then m times n, here's the matrix, is rectangle array. So this is the matrix. This is the first row, here's the second row, and keep going, the third row, fourth row, and keep going until the m row, row number m. And this is the column 1, column 2, keep going until column n. So now, if they're telling you the degree of the matrix is going to be the number of rows times the number of columns. If they ask you about the degree of the matrix, it's going to be the number of rows and the number of columns. So this is the first thing. We're going to check that when we do an examples. Elementary row operations, that's mean. The first one, interchange two equations. You can change two equations, number 1 to be number 2 and number 2 to be number 1. And the same thing with if you have row 3.
I'm sorry, I have a question. So are these used in research as well? These columns like this of numbers?
No, because we're gonna get just numbers.
Oh, okay.
Yeah, like I'm gonna show you with
Because
an
I feel like
example.
I've seen this before, so I was just checking.
Okay, you're fine. We're gonna do an examples about that. So that's why I just want to explain these before I'm going to the example. When we multiply an equations by a non-zero constant, add multiple of equations to another equations. Let's check that. That's how we're gonna see the sign. If you change row 1 with row 2, like row A with row B, if you multiply row A by a constant, so C is not equal to the 0, that's mean a number. If you multiply a row with number and add it with another row, so row A, row B. I'm just explaining these. Let's check how it's going to be if we do an example to show you how it's look like, because these notes are from the slides. So if we have this matrix, let's work with the system. We have this system like 2x1 plus, let's do it with xy, plus 3y equal 0. And the other equations is 5x plus 6y equal 7. So now this is the system of equations. System with two equations. This is number 1, this is number 2. Now I need to write down the augmented matrix, which is mean the matrix. So here is the matrix. I'm going to open two long bracket. The first thing I need to make sure here is the x's on one column, and here is the y on one column. That's me. I'm going to write down the coefficient here, 2. The coefficient here is 5. Then here is 3. Here is 6. This is look like the equal sign. Now it's 0 here, and here is 7. So this is the matrix. Or they can say it's the augmented matrix. That's what we're going to do. The first thing, how to convert the system to the matrix, augmented matrix. So we have negative 3x plus 6y plus 6 equals 0, and 7x minus y equal negative 13. So again, I need to write down the system. That's mean the variable, here's the x's, here's the y, and the number is going to be on the other side. So if you look to the first one, this is the system. I need to write down the system x, y, and the number on the other side. So the first equations, I'm going to write down the first equations again, negative 3x plus 6y. I'm going to move the 6 to the other side. So I'm going to say minus 6 from both sides. So it's going to be this equal negative 6. And the second one, I'm just going to write down 7x minus y equal negative 13. Now, you see the system, x, y, the number by itself on the other side. So now we're going to write down the augmented matrix, which is, and here is the equal sign. I'm going to write down the coefficients, negative 3, 7, and here is 6, negative 1, negative 1y, so negative 1. Here is negative 6 and negative 13. So this one is the matrix. That's it for this example. So this is called augmented matrix. So if we go to example 1, let's see. A matrix is when the number of rows equal to the number of columns. Like for example, if you have this matrix 5, 6, 3, 1. The number of rows, how many rows do we have? This is row 1 and this is row 2. We have 2 rows. Now, how many columns? This is column 1 and this one is column 2. So we have 2 rows and 2 columns. That's mean m times n. 2 rows and 2 columns. You're not going to multiply these two numbers. This is the degree of the matrix. That means we have 2 rows and 2 columns. Do not multiply these two numbers. 2 rows, 2 columns. When you have the number of rows equal to the number of columns, this matrix is called square matrix. So you're going to choose square matrix. That's it for this one. If you go to the second one, a matrix from a system, if you change the matrix to a system of linear equations, this is called what? Here's the system. And when you get the matrix, this is called augmented matrix. Augmented matrix of the system. If you check the number 3, 2 matrices are when one can obtain from the other by sequence of elementary row operation. 2 matrices are equivalent when one can obtain from the other, but we're going to do an example about that. We have 2 matrices and we're going to do some operation on matrix A to get the matrix B. So these 2 matrices is going to called equivalent or row equivalent. We're going to call it row equivalent. A matrix in row echelon form. This is one of the row operations. It's called row echelon form. If every column has leading 1, let's check that. A matrix in row echelon form is in reduced row echelon form. If every column that has leading 1 has 0 in every position above and below the leading coefficient. Let's check that how it's going to be the row echelon form. So you have a matrix in the reduced row echelon form. It's going to be like this. So you can know what's the meaning of reduced row echelon form. The reduced row echelon form, this is the leading coefficient, the first number. And every number under this leading coefficient, leading entry is equal zeros. Let's do like I'm doing matrix with 3 rows and 3 columns. The second column, here is the leading here is 0, and here is the leading entry. Also, it's going to be 1, and this one 0. And here is the third column, 0, 0, and 1. So you see the diagonal here. The diagonal is 1. Every element here is zeros. The diagonal here, the second leading entry, which is 1, on the top is 0, on the bottom is 0. The third one, the number here is 1, and every number on the top is going to be zeros. So this is called reduced row echelon form. Reduced row echelon form. We're going to check that when we solve the system. We have to convert the matrix to this form so we can find the solution. I'm going to show you how to convert that by doing row operation. So we're going to find the solution. So this is the reduced row echelon form. Every time when you have a number here, you're going to divide. So to convert the number in this location to 1, you're going to divide. To convert this number to 1, you're going also to divide. You convert the number here on this location to 1, you're going to divide. That's what we're going to do when we solve the system. And I'm going to show you that step by step. So this is the reduced row echelon form. Let's check the dimension. With the next example, they ask you about the dimension. So example 5, determine the dimension of the matrix. Check this matrix. This is a matrix with 1 equations. You see, because it's 1 row. So we have how many? Always you're going to write down the number of row and the number of columns. How many rows do we have here? Again, do not multiply the numbers. If you look to this example 5, we have only 1 row. So we have 1 row. And how many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 1 row and 10 columns. We're not going to multiply the numbers. So 1 row and 10 columns. That's the dimension, or that's the degree for this matrix. They call it dimension with 1 row and 10 columns. Let's check example 6. Example 6, let's check determine the dimension of the matrix. We have how many rows? We have 1. So this is 1 row, 2, 3. So we're going to type here 3 row. How many columns? 1, 2, 3, 4. 4 columns. So we're going to write down 3 row and 4 columns. If you flip it, if you write down the number of columns here and the number of rows here is going to be wrong. Because always the number of rows, then the number of columns. That's it for this example. Example 7. We're going to do the same thing. Write down a matrix with 6, with dimension 6 and 4. 6 and 4. So how many rows do you have? You have 6 rows. And how many columns? 4 columns. I didn't ask you which numbers you're going to choose. I just need you to write down matrix. So choose any number. So we're going to choose any number, but our goal is to write down matrix with this dimension, 6 rows. And how many columns? 4. So 6 rows, I'm going to say choose any number. 3, -1, 5, 6. This is row 1. Row 2, I'm going to choose any number. 5, 7, 3, -2. 4, 3, 1, -5. 6, 7, 8, 2. 5, 1, 3, let's say -1. -1, 6, 3, 2. Now tell me, what's the dimension for this matrix? The rows 1, 2, 3, 4, 5, 6. 6 rows. How many columns? 1, 2, 3, 4. That means here is the matrix with dimension 6 rows and 4 columns. I didn't ask you the numbers here, which numbers you're going to choose. So you're going to choose a random number. But our goal for this example is to write down matrix with 6 rows and 4 columns. Okay? Just
Okay,
the dimension. So if you check example 7, determine the dimension of this matrix. We have 1, 2, 3. We have 3 rows. How many columns? 1, 2, 3. We have 3 columns. So 3 rows and 3 columns. This is the dimension for this matrix. That's it. So example 8, they're going to ask you to write down the augmented matrix. So again, here is the system. And we need to write down the augmented matrix. So first of all, I need to check the system. The system, here is the X written, see, on the same column. And here is the Y and the number by itself on the other side. Here is the equal sign. So again, before you write down the system, do these steps. Check the X's on one, like the variables, exactly the same variable, and exactly the same variable, and the number by itself, the constant on the other side. Then I'm going to write down the coefficients. So I'm going to write down here 2, and the next number here on the bottom is, there is no number here, it's mean 1. And here is -1. And here I'm going to write down 1. Then you see these 2 dot, which is the same thing, the line. That means the number by itself on the other side, the constant is a 3, and here is 2. That's the only thing they ask you on this example, to write down the augmented matrix. Next example, we're going to do the same thing. We're going to write down the augmented matrix. The first thing, I'm going to check the variables. You see the x's on 1. Here is the y, the variable y, and here's the z. There's no z on the third equations. In this case, that means it's a 0. This is really important. That means it's 0. You're going to put in this location 0. So let's check how we're going to write down. The first coefficient here is 1. The second one is here is 9. And here is 4. Then for the y, it's -1. Be careful with the sign. If you forget the sign, if you put 1, everything's going to be wrong. The second one is -5. And the third one is 1. Here, the third column, we have 4, 1. So we have 4. And the second one is 1. You see, there is no z here. I'm not going to leave it an empty because we need to write down the matrix. That means 0, 0, z. Then I'm going to write down the constants here. The first one is 4. The second one is -1. The third one is 0. That's it for this example. Let's find the augmented matrix for this one, for the system. And if you look for the system, x, there is no x here. That means this is 0. 0x here. Here is the y, and here is the z, and here is the number by itself. So we're going to type here 9, and here 0. The second one is 1. And we're going to type here negative 18. Here is negative 3. And here is 14. And then on the other side is 13. And here is negative 7. And again, be careful when you write down the sign. Let's go to the next one. The next example, we're going to do the opposite thing. We have the augmented matrix and we need to write down the system. So let's check this example here. We have the matrix 1, 1, 8, negative 3. And we have on the other side 3, negative 1. Now we need to write down the system. So here they're telling you use the variables x, y, z, and w. That means you have to use these variables. But on the test, you can use any variable if they didn't mention that. So the first thing, the first column is for the x, the second column for the y, and here's the equal sign, and here's the number by itself, which is the constant. So to write down the matrix is going to be 1x plus 1y equal 3. 1x plus 1y equal 3. The second equation is going to be, we have 8x minus 3y equal, the number by itself on the other side is, the number on the side is equal negative 1. So this is the system. So now we can type here, the first equation is x plus y equal 3. And the second one is 8x minus 3y equal negative 1. So this is the system for this augmented matrix. We're going to do the same thing with the next example, but on the next example we have 3 rows and 3 columns. So you see these dots, that means this is the equal sign. So I have to choose 3 variables. I'm going to choose x, y, z. So that's the variable I'm going to choose, x, y, z. So the matrix we have, so this is for example 12. So I'm going to say this is for the x variable, this is for the y, and this is for the z. And here is the equal sign, and here is the constant. That means it's going to be 4x, 0y. So I'm not going to write down the y, plus 3z equal negative 11. This is the first one. The second one, there's no x. Start with the y. We have 1y minus 3z equals 7. The third one, we have x and y, there is no z. So we have 8x plus 5y, z equals 0, equal 5. So here is our system. This is the system for this augmented matrix. So we're going to type here 4x plus 3z equal negative 11. There's the equal sign. And here the second one is y minus 3z equals 7. And the third one is 8x plus 5y equal 5. We got example 12, right? Let's move on to example 13. Example 13, this is what's called row operation. Let's check that, how we're gonna do this example. They give you the choices about these, which one you're gonna do for matrix A. If you remember, we said two matrices are equivalent if we can do a one row operation on the first one to get the second matrix. Let's check that with example 13. So let's check these options here. Always start from the easiest one. That means which operation I can do it here to get this matrix. So that means I need to work here on this one. So this is R1 and this is R2. First of all, I'm gonna write down these in the small letters. Keep in your mind, always when I write down R1, this is mean the original or the old row one. R2, this is the old row 2. So you can know the difference. When I write down capital R1, this is the new row 1. Capital R2, this is the new row 1. And this is the new row 2. Because this is important. Let's check here. Let's start with the second one. Interchange row 1 with row 2. This is the first one. I'm going to skip this one. I'm going to go to the second one. The second one says the rule 3, add 3 times row 2 to R1. That means 3 times row 2, 3 times row 2, and add it to R1. This is the rule. That's what it says here. So this is our rule. We're going to multiply 3 times R2, and we're going to add it to the R1. So if you look to this matrix, which is -2, 3, 1, 5, -1, -6. I'm going to use this rule. 3 R2 plus R1. I'm going to start with the first one. If I multiply row 2 by 3, that means 3 times 5 3 times 5, 3, which is, here is R2. I'm going to start with the first element. 3 times the first element here and add it with the first element with the row 1. So 3 times R, 3 times 5 plus -2. Check how much the result. 3 times 5 is going to be 15 minus 2 is going to be 13. 13, which is the number here with the new matrix. So here's 5, -1, -6. You see, row 1, row 2 is exactly the same. Is that number? -8. It's not -6. It's -8. So you see this R2 is the same row, but the change in R1, you see R1 is different one. So now if I multiply 3 times 5, 3 times R2, which is 5, plus R1, which is -2. So 3 times 5 is 15, minus 2 is going to be 13, which is the number here. And exactly the same number here. Let's check the second one. If I multiply 3, because the rule says 3 times R2, but the second element here. So 3 times -1 plus R1, which is a 3, is going to be 3 times -1 is going to be -3. A plus 3, the result is going to be 0. Check the second element is 0. What we got here. Now let's see the third one. If we multiply 3 times -8, and you're going to add 1. 3 times -8 is going to be -24. Plus 1 going to be -23. So we're going to write down here -23. So this is the third element, which is exactly what we have here. So that means from these 3 options, it's not 3, 1, 2, 3, 5 options, this is the right option. If you multiply 3 times R1, R2, and add it to the R1, this matrix, the first row is going to be to change to this row. I mean, this matrix is equivalent to this one. If you do the same thing with the third option, the fourth option, the fifth one, you're not gonna get the new matrix. So that means only the second option is going to be the right one. Because if you multiply 3 times the second row and add it to the first row, the result, you're gonna get this new matrix. That's why this matrix is equivalent to this matrix by doing the second choice, by multiplying the 3 times the row 2 and add it to row 1. We're going to do the same thing with this example. Before we do this example, this is called row operation. So let's do this example before we move into 14. So here's the new matrix. I'm going to tell you, use this row operation. R1 equal 2 times R1 plus R2. This is the rule. Go ahead, use this rule to get the new matrix. So here's the old matrix. What's the meaning of capital R1? It's mean get a new R1. Get a new R1. That means the change is going to be on the first row. The second row is going to be exactly the same. So here's the second row, exactly the same. Because I am going to get a new R1. So R1, here's the new R1. I'm going to get a new R1. So R2 is going to be the same. Now let's check. The rule says the first element is going to be 2. Here's R1. 2 times 3 plus R2, which is 6. Now, 2 times 3 is going to be 6. 6 plus 6 is going to be 12. That means the first element is 12. Now, let's check the second element. The second element is going to be 2 times R2, which is R1 is 4, plus R2 is -1. 2 times 4 is going to be 8. 8 minus 1 is going to be 7. So here is 7. So this is our new matrix. This one is going to be equivalent to this one by do this row operation. So R2 is the same. We get a new R1. 3 became 12. 4 became 7. So for example, 14, here's the original matrix, and we need to get a new matrix. If you look to the difference between these two matrices, row 1, it's exactly the same. That means the change is going to be on R2. So I'm going to keep my mind. I'm going to get a new R2. Now let's check the first rule here. It says 4 times row 1, 4 times row 1 and add it to row 2. So let's check this rule. It's going to work. The change is going to be on R2, so we're going to get a new R2. So now I'm going to do the first element. The first element is going to be 4 times R1 is 3. Added to R2 is going to be equal. 4 times 3 is going to be 12. 12 minus 6 is going to be 6, which is the first element here. That means this is right. Let's check the second element. We have 4 times R1, which is -1, plus R2 is 9. So 4 times -1 is going to be -4. -4 plus 9 is going to be 5. So this is the second element. So we have 6 and we have 5. 5 is the second element on this new matrix. Let's check the third element. 4 times -4 plus 8. 4 times -4 is going to be -16. -16 plus 8 is going to be -8. So the third element here is -8. That means the first rule is the right one. That's it for this matrix. They're telling you add R2 to R1. So we're gonna add R2 to R1. That means we're gonna get a new R1. How are we gonna get a new R1? By add R2 to R1. So here is R2 and here is R1. That means the change is going to be on the first row. So we're gonna add these two rows. 7 added to -3 is going to be 4. 13 added to -5, so it's going to be 8. Next one, 1 added to -1 is going to be 0. So we see we just adding R1 to R2. We have to keep going. -51 added to 15, so it's going to be -36. So we're going to say here -36. We added, we get a new R1 by added R2 with R1. R2 here with R1, and the change is going to be on the first row. That means the second row and the third row is going to be the same. So -3, -5, -1, and we're going to put 15 here because we got a new R1, and 3, 6, 3 here, 6, negative, no, here's 1, and -23. Because our change is going to be only on the first row. We got a new R1. Now, what they're telling you, R1 multiplied by 1/4. That means we keep going, working on the same R1. So the change is going to be on this first row. So here's the thing. I'm not going to look here. I'm going to look to the new matrix. And I'm going to multiply the first row by 4. Sorry, divide by 1/4. That means you're going to divide or multiply the first row by 1/4. So the first element is going to be, before I'm going here, the change is going to be on the first row on R1. So R1. So R2 is going to be the same, -3, -5, -1, and 15. And R3 is going to be 3, 6, 3 and 6 and negative, 1, negative 23. Because again, we're gonna get a new R1 by multiplying R1, the old one, by 1/4. So 4 times 1/4 is going to be 1. 8 times 1/4 is going to be 2. 0 times 1/4 is going to be 0. 36, negative 36 times 1/4 is going to be negative 9. So here is our new matrix. Now let's see the third operation. That's what we're going to do when we solve the system. On this one, we're going to get a new R3. That's mean the change on the R3. Again, I'm not going to look to this matrix anymore. I'm going to look to the new matrix. The change on R3, that's mean R1 and R2 is going to be the same. You see, I'm going to type R1 and R2 the same. 2, 1, 0, and here is 0, and negative 9, and here is negative 8. Okay, so now we're going to get a new R3. What we're going to do, we're going to say negative 3 times R1. So I'm going to say negative 3. Here is the rule. Negative 3. I'm going to multiply by R1, by R3, and we're going to add R2. So negative 3 times 3, negative 3 times R3 and add to R2. Yes. Negative 3 times negative 3.
So
Yes.
we don't go back to R1?
It's supposed to be
thought
going
that's
to,
what you
it's
said.
supposed to be, oh, this is R1. Right. I'm talking, oh, this is R1. No, I did mistakes.
Okay.
This is R1. Good. Because I say, yes, we have to go to back R1. So negative 3 times R1, which is 1, and add it to R2. So negative 3 times 1, and you're going to add it to the R2, which is to add it to R3. Add it to the 3. So negative 3 times 1 is going to be negative 3. Added to R3, which is a 3, is going to be 0. Let's check the second one. Negative 3 times 2 is going to be negative 6. Negative 6 added to 6 is going to be 0. So the second row also is going to be 0. The third one.
Oh, okay. Hold on, because this is confusing right here. So you wouldn't go back up to the other R1 at the top. You just go to the one before it.
The new matrix here.
Okay.
So you see, I'm not going to use this one. I'm not going to use this one. I'm not going to use this one.
Okay.
Okay, this is the raw operation. We're going to do the same thing when we solve the system. I know it's a little bit hard, but it's going to be easier because I'm going to write down all the steps in the rule when we solve the system, which is example, I think, start 17, 18, 19, 20. Okay?
Okay.
So the second one is going to be negative 3 times 2, which is R1. You see the number 2 here? And add it to R3, which is 6. So I'm using this rule, be careful, but I'm using this matrix. I'm not gonna go to this one or this one. So negative 3 times 2 is going to be negative 6. Added to 6 is going to be 0. That's why we have 0 here. Now the third row is going to be negative 3 times R1, which is R1 here is 0, added to R3, which is 1. So the result here is going to be 1. Now we have to keep going. Negative 3 times negative 9 is going to be positive 27. Positive 27 added to negative 23 is going to be 4. Negative 3 times negative 9 is going to be positive 27. Positive 27 added to negative 23 is going to be 4. So now this is our new matrix. When I do the next operation here, I'm not going to go back here. That's it. I'm done from this matrix. I'm going to go and use this matrix. This is my new matrix, okay? Negative 2 times R2 and added to R1. Negative 2 times R2 and added to R1. The change is going to be on R1. So in this step, we're going to get a new R1. We're going to get a new R1. How are we going to get a new R1? By multiplying negative 2 times R2. That's mean here's my new matrix. R2 and R3 is going to be the same. So R2 is going to be 0, 1. I'm not going to do any change here. Negative 8. And here 0, 0. And here's 1. And here's 4. The change is going to be on R1. I'm going to get a new R1. How? By saying negative 2 times R2. So the first element, negative 2 times 0, which is here, is going to be 0. 0 add to 1, so this number is still 1. Now, negative 2 times 1 is going to be negative 2. Plus 2, the new element here is going to be 0. The third element here is going to be negative 2 times 0 is going to be 0. 0 add to the 0, still 0. Now, negative 2 times negative 8 is going to be 16, positive 16. Positive 16 added to negative 9 is going to be 7. So that means this element here is going to be 7. So this is our new matrix. We did the operation and we get this matrix. If you look to the new matrix, all elements here on the diagonal row is 1, and on the top 0, and on the bottom zeros. So in this case, this is the way to solve the system, and that's what we're going to learn next lecture, how to solve the system. That's mean x is going to be equal 7, y is going to be equal negative 8, and z is going to be equal 4. So we're going to do the same row operations here every time when you need to solve the system. X equal 7, y equal negative 8, and z equal 4. So that's how to solve the system. We're going to do exactly the same row operation. I'm going to do a chart next class, how to do each step. And we have to practice on it every time when they ask you solve the system by using the matrices.